Hello everyone, welcome to qphysicsacademy. This is Mithun Patra. I'm from NISER, SEPS, and I am a planetary science research scholar. Okay, this is our lecture number 7 of solid state physics, BSc semester 5, as well as others kind of competitive exams, CSIRNET, GATE, JEST, CSIRNET, etc. Okay, today we are actually discuss some special type of crystal structures, both all are NaCl structures, Dimond structures, ZNS structures, and CsCl crystal structures. Okay, we are discuss actually here on this all kind of special type of crystal structures. Okay, so let's start our class. Again, also I told you, if any student felt any kind of difficulty to digest my concept regarding subject, just you put a message, or just you could or you can type a comment in our YouTube channel. That's problems are actually we are face. Okay, and then I can try to resolve your problems. Okay, so don't be shy to told me your problems regarding solid state physics, as well as if you feel like any kind of personal problem, you also told me. Okay, don't worry. Okay, let's start our class. First of all, we have it. First structures is actually NaCl structures. Okay, NaCl structures. So NaCl structures, the structures of sodium chloride. NaCl is a classic example of ionic lattice. It's okay. This is a classic example of ionic lattice in these structures. Okay. Sodium ions, Na plus ions, and chloride ions, Cl minus ions, alternate in a regular repeating patterns. Actually, in NaCl crystal, Na plus and Cl plus ions are arranged in alternative manners. Actually. So one positions NaCl, Na plus ion is present, and another positions Cl minus ion is present, and this patterns is actually repeated consecutively. Then NaCl structures is actually formed. Okay, this is the first point. Second point is each sodium ion is surrounded by 6 chloride ion. This is very important point. Please remember this concept. Each sodium ion is surrounded by 6 chloride ion, and each chloride ion surrounded by 6 sodium ion and forming a cubic lattice. Okay, so in NaCl structures, each sodium ion is surrounded by 6 chloride ion, and each chloride ion surrounded by 6 sodium ion and forming a cubic lattice. Okay, that's the basic point. And this arrangement is known as the face center cubic lattice or cubic closed packed structures. It means NaCl structures is nothing but a FCC structures. Be careful. Okay, we discuss about that using some pictorial representations. We are just deal with you some basics of NaCl structures, and these 3 points are very important for your competitive exam purpose. Please read carefully about all these points. Okay, next, the strong electrostatics force between the strong electrostatics force one second. Yeah, that's fine. The strong electrostatics force between the oppositely charged ions, I mean Na plus ion and Cl plus ions, result in a stable and high melting solid. So NaCl's have a stable crystals, as well as high melting. It's have a high melting points. Why it's have a high melting points? Because the electrostatics force between oppositely charged ion due to strong electrostatic force between the oppositely charged ion. Result, NaCl is a stable crystals as well as it's have a high melting point. It's very important. This is asks your examinations like CUCT. Okay, so this point is very important also. Yeah, now we come to the pictorial form of NaCl structures. Actually there we given to you three pictures. Actually why we use three pictures? Each pictures have a each pictures have a own style for representations of NaCl structure. Actually three are uh, same. These 3 years actually same. I mean to you that is 3 hours for NaCl crystals, but I use here because your understanding purpose. Okay, so you can just see any figure number 1, and then this is a figure number 1. Okay, this is your figure number 1, and this is your figure number 2, and this is your figure number 3. Yeah. Just you can saw it, just you see it. Okay, just you see it. Here we mark down here Cl ion, which one is Cl ion, which one is Na plus ion, just you see. Okay, if you go through the picture number 2, I mean figure number 2, here actually this atom is nothing but a Cl minus atom, and then alternative there have a Na plus, and this is Cl minus, and then again Cl minus, and then again Na plus, and so on. Okay, Na plus. So as earlier we discussed, each sodium atom is surrounded by each sodium atom. If you consider, if you just look at the this atom. Okay, this is called, or this is the octahedral positions. This is the octahedral positions, and this positions is called side central. Please remember, side central positions. So here you can just go through figure number 2. Figure number 2, here this Na plus ions, actually surrounded by 6 Cl minus ions, right? 6 Cl minus ions. Okay, we are just write down the numbers. This is the first, this is the second. Okay, this is your this is your first, this is your second, this is your third, this is your 4, this is your 5, and this is your 6. Okay, this is your 6. So these atoms are actually surrounded by 6 Cl atoms. Okay, so we are already discussed in our previous points. Okay, next we go through figure number 3. I think it's looks better, right? I think it looks better. So Cl minus and Na black ball are actually Cl minus, and green balls are actually used here for Na plus ions. You also see here Cl minus and Na plus are alternatively repeated here and form a cubic lattice, right? Form a cubic lattice means if we just connect those points, if we just connect those these points and these points and these points, okay, these points, yeah, these points, this point, these points, I just yes, these points and these points and this point and this is okay. So okay, don't worry, I just mark it by another color. I just mark it by another colors. You just feel this concept, okay? I think you understand it, right? So in NaCl structures, actually one Na plus ions and one Cl minus ions are alternatively rearranged here and form a cubic structures. Okay. Yeah. So there are some points. We just try to understand also these 2 points. So this model made up by two FCC crystals. So NaCl can have a consider as two interpenetrating FCC structures. What is the concept? NaCl structures made up by two FCC crystals. Okay, two FCC crystals. I mean, NaCl can be considered as a interpenetrating two FCC lattice, and one lattice occupying the Na atoms. Okay, one lattice occupy the Na atoms and other occupy the Cl atoms. I mean, one FCC structure is made up with only Na atom, Na plus ion atoms, and this is FCC structures, and one FCC structure is made up with Cl atoms. Okay, we are just focus on these pictures from part 3. This is very easy. This is very easy. I think this picture is very helpful. This representation is quite well. This representation is very quite well, and such that one has the origins. I mean, one FCC lattice has the origins at 0, 0, and the other has the origins a by 2, 0, 0, or 0 a by 2, 0, 0, any of this. Okay, we are just now try to understand the formations of NaCl structures. Okay, if you just focus the black balls, okay, if you just focus the black ball, this black ball are if you just connect all the black balls, then you get a FCC lattice. Okay, and for this FCC lattice, for each face means, I mean to say, slide central. At the slide central point, this point is called slide center. Okay, this is called slide center, right? This is called slide center. This point is called slide center, and also this point is called slide center. all these are slide central. At the slide central point are Na plus ions are actually present. Okay, so if we just forgot all the Na plus ion and connect all black balls, then we get a crystals, cubic crystals. But if we put all the green ball, then we get a CsCl structures. Again, we forgot about all black balls and connect all the rest of the green ball, then you get again a cubic structures. And if you put all the black ball, you get a FCC structures. Okay, so if we consider a FCC structures which is made of with Cl minus ions, its origins is actually located here. This is nothing but 0, 0. But if you consider green ball which made a FCC lattice also, whose if you consider the lattice parameter is A, if we consider the lattice parameter is A, okay, lattice parameter is A, then the positions of this Na plus atoms is A by 2. This is the x-axis. If you consider x-axis, then this also this positions of this atom along y-axis is 0, A by 2, 0. And if we consider this atom, this is the z-axis. Okay, so the origin is nothing but at A by 2. This is the point actually here. So if we just remember, NaCl structures is nothing but a made of with 2 FCC crystals. Okay, 2 FCC crystals, and 1 FCC crystal is made of with Na plus ion, whose origins is located any of the origins. If you actually if you choose वो आपकी मर्जी है, ठीक है, this is your own choice. I mean to say this is your own choice. And another FCC crystals made up with Cl minus ion, and this all Cl minus ions are located at the origins 0.00000 points. This is the point actually. I think this is the basic idea about the NaCl crystal structures. Okay, next we go to some points about NaCl structures. NaCl structures actually have a non-primitive unit cell. Okay, NaCl structures have a non-primitive unit cell because we just pick a unit cell. This is the unit cell. This is a unit cell. Okay, this here Na plus ion and Cl plus ions are already present here. So just look, this atoms, this Cl minus atoms is here, and another side also Cl minus atoms, another side also is Cl minus atoms is here present here. Okay, this is there, here is also a Cl minus atom is present here. Okay, so this is the unit cell. This is the unit cell of NaCl, NaCl. Okay, unit cell of unit cell. So as we already discussed in previous classes, if coatoms are present only at the corner, then this unit cell is called primitive unit cell. But except corner, if atoms are present at the face or the body center positions of this crystal or unit cell, then this unit cell is called non-primitive unit cells. So NaCl structures have a non-primitive unit cell. Okay, this is your explanations. NaCl structures have a non-primitive unit cell. You just and this is the FCC structures. Okay, FCC structures. FCC. We just focus about that FCC structures. Now, next point is very important. Next point is number of atoms per unit cell or effective number of atom. Okay, number of atom per unit cell for any CL crystal structures. So there is a two contributions actually. There are two contributions. Contributions for Cl minus and contributions for Na plus. There are two contributions for Cl minus and contributions for Na plus. Actually, one FCC lattice is made up with Cl minus ions, or one FCC lattice is made up with Na plus ions. So the total contributions of Cl, I just calculate total contributions of Cl. It is equals to Cl's. We just use the formula that is nothing but 1 by 8 in C plus 1 by 2 NF plus Ni. Okay, Ni is for Cl. So for all, if we consider unit cell, at the positions of corner there are only 8 atoms. We already know for Cl, because Cls are always located at the corner positions. We are already deal with this point, right? So this is equals to 8 plus half into NF. I mean to say you Cl minus atoms also present in your FCC phase positions. This is the points. Figure is already in your screen. Okay, so we know for a unit cell there are 6 phases, so it's a 6, and no Cl minus atoms is actually present inside, but I means body center positions. Okay, at the body center positions only Na plus ion is present already. We are discuss about that. Okay, so its value is 0. So 1 plus 3 plus 4. So total contributions. So for NaCl crystals, number of Cl atom is equals to 4. Okay, number of Cl atom is equals to 4, and the contributions of the total contributions of Na. Okay, Na actually Na plus atoms are present at the side central positions. Okay, you just look at the pictures of Na. Okay, you just look at any of this. Na plus, this is Na plus, right? This is your Na plus. Na plus, this is your Na plus, this is your Na plus, right? Actually, Na plus ions are present at the body center positions, right? Na plus ions are actually located at the body center positions at side central positions. Okay, body center positions at side central positions. Side central means if we consider a face, and each face have a 4 side, right? If you consider a face and each face have a 4 side, and all Na plus ion atoms are present each 4 side, center of the site, right? This is the point I actually say. You Na plus ion are present at 2 points. One point is the central point, body center point of the whole crystals, And another position is if we consider a face of a crystals, and this face have a 4 side, okay, and if you just pick a one side, and the middle positions of this side, they have a 1 Na plus ion atoms. Okay, this is the positions of Na plus ion atoms, right? This is the positions of Na plus ion atoms. So Na plus ions atoms have a 2 positions. One is the side central positions. So for side central positions, there's a 4 side, and there are atoms is actually 12. Okay, there is a number of atoms is actually 12, right? Because there are 6 phase, there are 6 phase, and each phase, if you consider each phase, there are 2 atoms. Just contributions only 2 atoms, right? If you consider one phase and there is a 4 side, and 4 side, and each phase, for each phase there is only 2 atom contribute here. Okay, so okay, so there is 12 atom plus 1 atoms for central positions. So this is for your side central, and this is for your central positions. So this is equals to 3 plus 1, so this is equals to again 4. So number of atoms, number of Cl atom per unit cell is equals to 4. Number of Na atoms per unit cell is equals to also 4. So both are same. Okay, so actually in examination they ask you how many number of Cl atoms in a unit cells. You just say 4. Similarly, how many Na atoms in a per unit cell, you just say the number is 4. Just be careful. But if they ask you how many total number of atoms in NaCl, then you just say 4 Cl and 4 Na. So we just take a note here. Note here for NaCl, they have 4 Cl and 4 Na atom per unit cell. And this is the molecular crystal structures. Actually, this is note number 1, and note number 2. And NaCl is a molecular crystal structures. Okay, I just clear about that points. Okay, so this is the number of atoms per unit cell calculations. Okay, next we go to the point number 3. This is the coordination number or nearest neighbor distance. Actually here nearest neighbor means for any atom, if you pick a atom Na, for any atoms this nearest neighbor atom is Cl atom, and if you pick Cl atom, the nearest neighbor atoms is Na atoms. right? So nearest neighbors of, if we take a points, nearest neighbor of NaHCl. So we already discussed H each Na, it's surrounded by six Cl atom. So coordination number is obviously 6. So coordination number is obviously 6, right? Next we go to the nearest neighbor distance. We always know, for calculating nearest neighbor distance, we just find out the positions of nearest neighbor atoms. Okay, nearest neighbor distance, it means positions of nearest atom, positions of nearest atom, right? So here positions of nearest atoms means this is, and this is, and this is the Cl minus, and this is Na plus. Okay, this is the positions. So for this radius is called RCl, and this radius is called RNA. So total distance is nothing but RCl plus RNA, and it is equals to actually A by 2, right? This is actually A by 2. So nearest neighbor distance is equals to RCl plus RNA is equals to A by 2. Just be careful about that. Okay, very good. Next we go to the second point, is the second nearest neighbor. Okay, second nearest neighbor means, what is the meaning of second nearest neighbor? Second nearest neighbor means second nearest neighbor for Na atom, second nearest neighbor is the Na atom, and if we consider Cl atom, second nearest neighbor atom is only Cl atoms. Okay, so for Na atoms, second nearest neighbor is Na atom, and for Cl is also same. Okay, so it is very clear, if we consider sodium, right? Just look at the pictures. If we consider sodium, this atom, if we consider this atom, okay, and this atom is surrounded by, actually if we just mark down all the atoms, This is atom number 1. Okay, just focus each planes. If we consider this plane, and if we consider this plane, and if we consider this plane, this considers 3 layers. This is layer number 1. Let's consider layer number 2, and just consider layer number 3. Each layers have a 4 atoms. Each layer has 4 atoms. So there is a 3 layers and 3 layer structures. NaCl is a 3 layer structures actually. So here we get the coordination numbers. I mean NaCl atoms is surrounded by 4 Na atoms. 1 Na atoms is surrounded by 12 Na atoms. In the similar manner, 1 Cl atom is surrounded by 12 Cl atoms. This is the second nearest near. This is the second nearest near. You just clear about that. I think you just clear. So the second nearest number. So second nearest near number is equals to 4 into 3. 4 into 3. 4 stands for number of atoms, number of Na atoms. 3 stands here, number of layers, number of layers. Okay, I think you be clear, and that is equals to actually 12. That is actually 12. And the second nearest neighbor distance is very easy. That is equals to A. That is equals to A for one atom to another sodium atom. That is equals to A. Okay. So second nearest near distance equals to A for sodium. I mean NaCl for NaCl. Yeah. Next we go to the second nearest distance, which already we discussed here, point number 6. Just you write down. Next, volume of unit cell is equals to. Next, another point is volume of unit cell. Volume of unit cell that is equals to A cube. Volume of primitive unit cell. These points are very, very important. Volume of primitive unit cell as this is FCC structures, so A cube upon 4. This is FCC structures, A cube upon 4. Yeah. Okay. So let's have some example of NaCl structures. Like NaCl structures, use just some example. Let's have the same type of structures, that is KCl, KBr and AgBr. Both have NaCl structures. They have structures. They have structure like NaCl, like NaCl. Okay. Then take a note. Please take a note. This is very, very important in your competitive exam purpose. So note it. All the alkali halide, all the sorry, alkali halide and silver halide and silver halide have NaCl structures. Okay, NaCl structures. Here alkali halide means what is the meaning of alkali halide? Okay, just we get clear here. Alkali halides, it means NaCl, NaCl, okay, KCl, okay, NaBr, okay, KBr, okay, Na iodine, it's okay, Ki, it's okay. So these all are the example of like NaCl structures, have NaCl structures. Okay, I think you not confused. Other time they have NaCl structures. Yeah, this is your NaCl structures. I already give some informations about NaCl structures. Next we go to the points. Another point is Dimond structures. Okay, next point is Dimond structures. Next we discuss about the Dimond structures. What is Dimond structure, and we calculate all the properties for Dimond structures one by one. Yeah, Dimond structures or Dimond cubic lattice can have considered as a interpenetrate up to FCC lattice. This is also interpenetrations up to FCC lattice, right? Dimond structures is also nothing but interpenetrations, not interpretations, interpenetrations up to FCC lattice, like NaCl structures. So one is at the positions, one FCC lattice origins actually at the positions as 0, 0, 0, and other FCC lattice have the positions 1 by 4, 1 by 4, 1 by 4. Okay, I just give you some discuss. We just discuss one point. Okay, so for Dimond crystals is the interpenetrations of two FCC lattice. One FCC lattice whose origins are actually located at the position 0, 0, 0, and another positions of atoms of another FCC lattice is 1 by 4, 1 by 4, 1 by 4. Okay, is it clear? Okay, is it clear? You just go through the pictorial form. Just go through the pictorial form, and we all you just I discuss. Okay, now this is a non-primitive unit cell. Yeah, obviously it's a non-primitive unit cell. When you go through this pictorial form, it's have a non-primitive unit cells. Next we calculate the number of atoms per unit cell. That is very, very important. Number of atom per unit cell. Number of atom per unit cell. Okay, we just use the figure 2. We just use figure 2 to calculate number of atom per unit cell. This is figure 2. Okay, So for calculate the number of atom per unit cell, we use this formula 1 by 8 NC plus 1 by 2 NF plus Ni. Okay, you just look the figure 2. Here all there are 8 corners atom. It's very easy. We are just, it is very easy. Plus face, whose atoms are actually at the face. Yeah, obviously 6 atoms. There is a 6 face. You know, there are 6. There are atoms also at the position at the face, and also there are atoms at the inside the crystals. I mean inside the crystals. You know, actually diamond crystals, if we pick a unit cell of diamond crystal, this is non-primitive because atoms are located at the corner as well as face as the inside of the crystals, inside the unit cell. Okay, so at the corner there will be 8 atoms, at the face there will be 6 atoms, but at the inside, how many atoms are actually located? Okay, inside you just count. This is the number 1, this is the number 2, this is the number 3, and this is the number 4. Okay, I just count all the numbers atoms. Actually these atoms are actually located at the face. These atoms, all are atom actually in the face. Their position is actually in the face. So inside the crystals or inside the unit cells there are 4 atoms. Okay, there are 4 atoms. So 1 plus 3 plus 4 equals to 8. So for diamond structures, okay, so for diamond structures there will be number of atoms or effective number of atom per unit cell is equals to 8. Okay, next we go another point. This is coordination number. Okay, for coordination numbers mean the first nearest neighbor atom. Okay, actually diamond is made up with carbon. Okay, you just write down the point. Diamond is made up with carbon. Okay, diamond is made up with carbon. So each carbon atom, let's just go through these pictures. You just consider this is the carbon atom, this is the carbon atom. You just go through, this is the carbon atom. Okay, and this carbon atoms is surrounded by at the nearest neighbor point is equals to, this is the number 1, this is the number 2, this is the number 3, oh sorry, sorry, this is the carbon atom. Actually 3 by 4, this is the number 1, No, 1 by 4. I mean 1 by 4. Yeah. It's good. 1 by 4. This is the number 1. This is the number 4. And as well, I just here present in front of you just one phase. Just one part, one dimensions. Well, if you consider 3 dimensions, so just look at the 3 dimensions. If I just look at the 3 dimensions, just these are the this point, this number, this number, this number, this number. These are the positions at 1 by 4, 1 by 4, 1 by 4, 1 by 4, 0, 0, and 1 by 0, 1 by 4, 0, and 0, 0, 1 by 4 at this point actually. Okay, and carbon atom is already here. Carbon atom is already here. So nearest neighbor, so coordination number of diamond crystals actually 4. Nearest neighbor coordination number. So each carbon atom, each coordinate to 4 carbon atoms. 4 carbon atoms. So it's a coordination number equals to 4. Okay. So lesser than the coordination number, तो structure will be loosely packed. It's तो लिख लेते हैं हम लोग. So lesser than the coordination number hence structure is loosely packed. Okay, loosely packed. Next point is nearest nearby distance. Next point, for diamond crystals, we calculate the nearest nearby distance. Nearest nearby distance means body diagonal distance. Actually, body diagonal distance. I mean, just calculate. Just okay, write down the point. Body diagonal distance. It is obviously body diagonal है ना. Body diagonal इस तरह का distance होगा. Body diagonal distance of 0 point of atoms and atoms at 1 by 4, 1 by 4, 1 by 4, because this point this is the nearest neighbor atoms actually. Okay, so body diagonal distance. So body diagonal of cubic lattice is nothing but root 3a है ना. Body diagonal of cubic lattice we are already know body diagonal is equals to actually root 2a whole square plus a square. We already discussed for body centric cubic lattice, है ना? So that is equals to actually root 3a square. So that is equals to root 3a. This is the body diagonal distance. But here nearest neighbor distance means the distance between zero atoms or at the position 0 0 and at the positions 1 by 4 1 by 4 1 by 4. So nearest neighbor distance is equals to, it is very easy, nearest neighbor distance equals to root 3a by 4. इट इज़ वेरी इजी, क्योंकि 4 से डिवाइड करना होगा, क्योंकि एटम का पोजीशंस हाफ में नहीं है, 1/4 में है ना? अरे एक्चुअली अब वेरी सिंपल वे में है, अब समझ लीजिए, ठीक है? इससे लेके, ठीक है, ए बी डिस्टेंस है। अगर एटम यहाँ पे आएगा हाफ पोजीशंस में है तो डिस्टेंस क्या होगा? हाफ होगा। अगर डिस्टेंस यहाँ पे है, यहाँ पे है, दिस इज फर्स्ट पार्ट, दिस इज द सेकेंड पार्ट, दिस इज द थर्ड पार्ट एंड दिस इज द फोर्थ पार्ट। सो व्हाट इज द डिस्टेंस? ए बी अपॉन 4, यस और नो, है ना? ए बी अपॉन 4, वी जस्ट डू दिस or just do this. Okay, so for Dimond cubic lattice, nearest neighbor distance is root 3a upon 4. Okay, just clear it. Next point is a second nearest neighbor distance, and we also calculate the second nearest number. Okay, so for second nearest neighbor, okay, if O means this atoms, okay, this atom, if O is the reference atom, okay, just if O is the reference atom, then second nearest neighbor atom will be its face centered atom. Its face centered atom. ओके, इसके फेस में जितनी एटम्स है वो सारे होने वाला है। तो आप काउंट कीजिए इसके फेस में कितनी एटम्स है, ठीक है? इतनी फेस में कितनी एटम्स होगा? 6 फेस है, ईच फेस में 2 एटम्स है एक्चुअली। एक 1/4 और 3/4 में है, फोटो देखो। एक 1/4 पोजीशंस पे है और एक 3/4 पे है। जस्ट फोकस। मैंने आई जस्ट हियर शो यू वन फेस, दिस इज वन फेस, ओके। यू जस्ट शो द पिक्चर्स at the face, and there will be 2 atoms, okay, one atom at the positions 1/4, another atom is at the positions 3/4. At the cubic lattice there is 6 face, so second nearest atoms is equals to 12, obviously 12. Okay, so number is, so number equals to 2 into 6 equals to 12. Here 2 is for number of atom for each phase, number of atoms for each phase, and 6 for number of phase, total number of phase. Total number of phase. I think I clear you. Okay. Yeah. Okay. Now, what is the distance of second nearest neighbor? It is also very important. Distance of second nearest neighbor है ना. सेकेंड नियरेस्ट नेबियर मतलब जो फेस में एटॉम है, जितना फेस में एटॉम्स है, सारे फेस एटॉम का डिस्टेंस लेना पड़ेगा. तो क्या है उसका डिस्टेंस, हम लोग क्या लेंगे, देखो आराम से ये लेंगे ना, नीचे वाला फेस ले लो. ठीक है, नीचे वाला फेस ले लो. यू जस्ट पिक द बेस फेस and this distance, right? This distance is called second nearest neighbor distance. Okay, and this is equals to root 2 by 2, that means a by root 2 है ना. Okay, क्योंकि second nearest atoms will be the its face center atom, its face center atom. Okay, so from the origins, the distance of these face center atoms is equals to half of the diagonal of face, right? Diagonal of face, any face. Okay, so next point we just write here, second nearest distance equals to root 2 a by 2, and that is equals to a by root 2. Root 2 is the diagonal length of the diagonal of each face. Okay, I think clear about that, how to calculate the first nearest neighbor, how to calculate the second nearest neighbor, and how to calculate the number of first neighbor and coordination number. Just you can focus about that. Okay, and next point is volume of unit cell. It's very easy. Volume of unit cell is Q. Volume of unit cell is equals to Q. But next, volume of primitive unit cell. Next, this is also FCC lattice. This is also FCC lattice. So volume of primitive cell is equals to A cube by 4. That is very easy. Yeah. Next point is very important, is the atomic packing fractions of Dimond crystals. It is a very important questions for your IITJAM and all examinations. It is very important. All you know, atomic packing fractions. What is the mathematical form of atomic packing fractions? APF is equals to, actually, effective number of atom into volume of one atom by volume of unit cell. ये तो होता है, but volume of one atom, effective number of atoms you already calculate, right? This is the value of 8. Volume of one atom, for calculate volume of one atom, first of all we calculate the radius of one atoms. Okay, calculate the radius of one atom. the radius of one atom. We always say that when you calculate the radius of one atoms, we just focus the nearest neighbor distance. Okay, here we get already nearest neighbor distance is the 1/4 of body diagonal distance. Okay, 1/4 of body diagonal distance. So actually distance between two atoms is the nearest neighbor distance, right? So distance between two atoms in terms of radius of atom is nothing but 2r, है ना? Okay, okay, just clear. Again I say you that when we calculate the radius of one atom, we just focus the distance of nearest neighbor atom, है ना? For Dimond structure, nearest neighbor atom distance is equals to 1/4 of body diagonal distance, right? Also, distance between two atoms in terms of radius of each atoms is nothing but r plus r, that is 2r. Okay, so for calculating a radius of one atoms, we just use these mathematical expressions. Distance of two atom in terms of radius, and this is equals to distance of first nearest neighbor atoms, है ना? Actually I want to say distance of nearest atom equals to distance of nearest atom in terms of radius of each atom, है ना? So that is equals to √3a/4, you already calculate, and distance of two atom is equals to r plus r. That is all atom are same, actually carbon, that's why r plus r. But for the sodium, there is a one atom is Na and one atom Cl, so Rna plus RCl. We're just clear about that. Okay, so it is equals to 2r equals to √3a/4 and r equals to √3a/8. This is the radius of one atom. I think you're clear about that. Okay, now we calculate the atomic packing fractions. That is equals to effective number of atom is 8, volume is 4/r cube, r means √3a/8 whole cube upon volume of unit cell. Okay, if we calculate about, we get this value √3π/16, and that is equals to 0.34, and that is nothing but 34%. Okay, please remember this point. For Dimond structures, atomic packing fractions and radius, the first neighbor distance, is all about that. Okay, that's fine. This all parameters are we are calculate for also Dimond structures. Next, we go to the cesium chloride structures. Cesium chloride structures. Next we go to the cesium chloride structures. Yeah, this is the structures of cesium chloride. Cesium chloride structures. CsCl crystals can be considered as a two interpenetrating simple cubic lattice. Be careful. In previous two crystals, NaCl and Dimonds, they are interpenetrating up to FCC crystals, but cesium chloride CsCl is interpenetrating of two simple cubic crystals. Okay, just be careful. One has the atoms of cesium. I mean one simple cubic crystals made up with cesium, and another simple cubic crystals made up with Cl. Okay, I think you clear about that. And the origin of one lattice, of one simple cubic lattice, is at 0 0 0, and another is hop. Okay, is it clear? Not 1 by 4, this is half. 1 by 4 means atoms are present inside the crystals. 1 by half means atoms are present at the face. Just be clear. No, I just tell you wrongly na. One second. I just read about that. The origins of one lattice is at point 0 0 0, and there is half. Okay. I just clear it. Half means it is located at the body center positions of a cubic lattice which is made of CS. Just look at the pictures. What is the meaning of this line? These alls are Cl atom. These green balls are Cls, and Cs is located at the inside of the cubic lattice made up with Cl. Okay. So actually this Cl atom has the locations at 0 0 0, and this Cs atoms have a locations at half. Okay, just clear about that, right? Okay. So I just summarize 3 points: NaCl, Dimond, and CsCl. NaCl and Dimonds are made up with 2 FCC lattice, but CsCl, cesium chloride crystals, made up with 2 simple cubic crystals. Okay. For NaCls, one FCC lattice made up with Na, another FCC lattice made up with Cl. Okay, and the positions of Cl at 0 0 0 and the positions of Na at the side central positions. It means A by 2, 0 0 0, or 0 A by 2, 0, or 0 0 A by 2 for NaCl. Okay. Next we come to the sodium Dimond structure. Again, Dimond structures have a this is interpenetrating of 2 FCC lattice, right? And here all atoms are actually carbons. Okay, Here one carbon atoms is present at 0, 0, 0 and another carbon atom is located at 1 by 4, 1 by 4, 1 by 4. Okay, so it means it is not exactly the body center point. It is not exactly the body center of this unit cell, but it inside the unit cell. But for CsCl, it is made up with two simple cubic crystals. One simple cubic crystals, one simple cubic crystals with Cs, another simple cubic crystals with Cl. But here Cl are located at 0, 0, 0, but Cs atom is located exactly inside the simple cubic crystals. This is the point. Just be clear about that. Okay, and this is also a non-primitive unit cell. It's very easy. We all know this is a non-primitive unit cell. Next, we calculate the number of atom per unit cell. Okay, number of atom per unit cells, but it's there also two contributions for Cl plus contributions for Cs. So for contributions of Cl, Cl is actually 1. This contributions is 1 plus contributions of Cs is only at the corner position. This is because a simple cubic, so 8. So this is equals to 1 Cl plus 1 Cs atom. Okay, 1 Cs atom. Yeah, that's fine. Next is the coordination number. Coordination number actually is very easy. If you next second. Okay, it's already here. Yeah, Cs plus ions or atoms is actually surrounded by 8 corners atoms, right? 8 corners atoms. If we take the origins is here, right? It is take the origins is here. Yes, this is fine. If we take origins is here, Cs plus plus. Just imagine if you see, take origin Cs plus plus, and then it's surrounded by 8 corners atoms. So it's a coordination number. First coordination number or first nearest neighbor atom number is equals to 8. It's very easy. Just you look at the pictures. Don't bother about that. Okay, coordination number is equals to 8. Okay, and nearest neighbor distance is equals to just half of the body diagonal. I just show you. First nearest neighbor distance is equals to half of this distance, right? This is the distance of first nearest neighbor distance. So it is nothing but the half of the body diagonal length. This is the half of the body diagonal length. So it's all are very easy. Just you practice all this figure and clear about that. So first nearest neighbor distance. First nearest neighbor distance equals to root 3a by 2. Okay. Third point, second nearest neighbor, second nearest neighbor. Okay, second nearest neighbor is actually look the second pictures. So just look you second pictures. Okay, if this is the CS plus atoms, second nearest atoms are, this is the second, this is second. Okay, these are the second atoms, second and second. Actually, okay, these atoms are surround surround CS plus atom. Okay, just look this atoms orientations actually along the face, along face, along face, है ना, along face. Actually this atoms is located here, this directions, this directions, this directions, and so on and so on, surrounded it is here. Consider there have a Cl, there have a Cl, there also a Cl atom. Okay, there have also a Cl atom, and so on. Also a or two faces are already here. So it means Cs plus atoms is surrounded by another Cs plus atoms, not Cs, sorry. These all are Cs plus. Okay, these all are Cs plus. Okay, so Cs plus atoms is surrounded by another Cs plus atoms is by 6, right? 6 face for its value is 6. Okay, so for second nearest, for second nearest neighbor, Cs plus atom surrounded by others Cs plus atom. So its number is 6. Okay, yeah, and second nearest distance is very easy, है ना? Second nearest distance is also very easy. It's just a distance, this distance. Just focus. Okay, this distance, this is distance, this distance is called second nearest neighbor distance, है ना? This distance is called second nearest neighbor distance, just distance, that is equals to A. So distance equals to just A. Volume of unit cell, volume of primitive unit cells, its all are very easy. Watch. Volume of unit cell equals to A cube. Volume of primitive unit cell also A cube. Okay, and 6 point for NaCl, actually here RCS plus RCl, that is equals to root 3 by 2. It's a point. Yeah, I already discussed about that. Okay. Now for CsCl structures have some example. Let me just clear here. CsCl, it's always RBCl and CsBr and lithium He. Is all at the they have the same type of structures. Okay, I mean they are interpenetrating up to simple cubic structures. Okay, so please remember their structures. Please remember how to calculate with first neighbor atom, second nearest neighbor atoms. Especially NaCl or Dimond structures are very important. Especially they are very important for your competitive exam purpose. They ask lots of time, many times in your examinations. So be careful and prepare all the things in very well and make a notes in your make a notes in very well form, otherwise you not to able revise everything in a very small time. Just make a very good note. Okay, and next point is that we are just clear, we are just complete my first part of crystallography. Okay, next day, I mean this week, tomorrow I'll start reciprocal lattice classes. Reciprocal lattice class. And okay, tomorrow I solve all the previous year questions also. No, I have a plan. Tomorrow take reciprocal lattice class. Okay, reciprocal lattice. And some basic crystallography. Okay, I mean basic crystallography means I discuss some problems based on books, and we discuss some important concept also for SSE, BCC and simple cubic. There are lots of problems. I actually deal with you planes in different crystals, actually which planes are actually valid allows for simple cubic crystals, and for BCC which planes are actually allowed. We discussed in details. We already learned about in very little amount. We are learned about this concept in very little amount, but tomorrow we discuss in details planes in different crystals actually. Okay, and also we calculate some other parameters also, right? Okay, that's fine. And also discuss direction indices. Yeah, that is very important. Yeah, direction indices. Okay, this all are we are deal in our next class, tomorrow class. Okay, thank you. तो आप लोग अच्छे से लर्न करने सीखिए. Any problems, just send me a message in our WhatsApp group, and please do all homework and send our WhatsApp group. Hence I have to check all your problems, right? So okay, don't worry, पढ़ते रहिए. And today's class is finished now. Again, thank you for watching this video, and please subscribe and like. Okay.